Okay, true and false is the last section. You just have to be really careful with these. I think when in doubt, put some numbers in. If you can't remember the rule, put some numbers in. Don't use 0 or 1. Make sure you put some numbers in and C, use 2 and 3, or if you have A, B, and C, 2, 3, and 4. I'll show you some of the algebra behind these. 23, I have A plus B quantity squared. That is this. That's A plus B times itself. And usually if you rewrite it like that, then you know, hey, there's going to be a middle term. So that would be 2AB there in the middle. So since this guy does not have a middle term, this is false. 24 is kind of a hard one to see sometimes, I think, but you can break up a fraction over a common denominator. And I think if it was written in the other order, kind of this first and then that, it would be easier to see. But you can absolutely write 2 fractions over a common denominator or break up a fraction over a common denominator. So this one is true. That's not a bad one to put some numbers in and then simplify. Both sides would absolutely be equal. Now, although you can break up over a common denominator, you can't break up over the numerator. So 25 is false. That does not work. And I think that you would see it if you picked some numbers. So let's say I use 2 for A, 3 for B, and 4 for C. So the other side would be 4 for C, I said 2 for A and 3 for B. So here, if I worked on just this side, that I just plugged in some numbers, it would be 4 over -1. So that side would be equal to -4. There is no way I'm going to get -4 out of that subtraction. But you're welcome to do it. So that guy is false. Some more for you. A squared plus B squared, the square root of it is not the same as A plus B. Well, the rule here, if you had been squaring both like that, you could absolutely say that was true. But we can't take the square root if only the little singlets are squared there. We can't take the square root over that addition. Again, some numbers can be helpful. If we use A and B, if we use 2 and 3, so 2 squared is 4, 3 squared is 9, so that would give me the square root of 13 on the left side. If I put 2 and 3 in for A and B on the right side, 2 plus 3 is 5. 5 and the square root of 13 are not the same, so that guy is false. Same idea with 27. 27 is false. We can't break up over that addition. That's a good one to put some numbers in as well. 28. For 28, if you look at this side and think the left side and think exponent rules, a negative exponent is going to drop just that piece into the denominator. So the way that we would simplify 2 times a to the -1 is leave the 2 on top and then drop the a to the first to the denominator and make that exponent positive. So this is all kinds of wrong. The 2 is in the denominator, the -1 is on top, so it's all kinds of wrong. This is false. Couple more. 29 is a very commonly missed problem. A times B times C. This is just, the reason I put this on here is because multiplication is something that can be tricky, even though that it's something that you do every day. Once you start seeing it with lots of variables, sometimes you make mistakes. So here, with multiplication, order doesn't matter. These parentheses are just here to be a grouping for the B and C. You could write this in any order that you wanted, and it's the same problem. what you can't do is use that a twice. It's not a squared times b times c. And that's what this does here. This takes, here, this other side kind of distributed that a into the b and the c. We don't distribute when we have all multiplication. This one is false. Again, a really good one to put numbers into. Do not use 1 and 0. Obviously, 1 and 0 are very special numbers. But if you use 2, 3, and 4, even if you do that grouping, 2 times 12 is 24. On this other side, we said we're using 2 and 3 and 4. So now here, we're doing 2 times 3 is 6, 2 times 4 is 8, and that is definitely not 24. All right, 2 more. Another logarithm problem. So the thing to remember here is that if you have a log with no base, it's a log base 10. So I'm going to rewrite that here. 10 is the base. B is going to be your exponent. And a is on the other side of the equal sign. So I'm going to rewrite this side. 10 to the b equals a. And that is not the same as that. Last one is just a little order of operations problem. I'm going to first do this exponent. -6 to the third is, so negative to the third is a negative. 6 to the third is 216. On this other side, the negative is outside of what we are, of what we're doing here. So this is negative 2, or sorry, we can actually do 2 to the third. So that's going to be negative 2 to the third is 8. So we have negative on both sides, but 1/3 of 216 is definitely not negative 8. It's actually negative 17. So those are not equal. So this one is false as well. You will see a few of these, not a ton. So you will have plenty of time to work kind of some baby steps on these to see if you can get each side to match. Again, my advice on these, if you're feeling a little bit unsure, is to put some numbers in. If you don't have numbers, if you're just looking at variables, put in some numbers, don't use 1 and 0, and see if each side of that little equation is true, or that if you can get the two sides to match. All right, I hope the videos for practice test 1 were helpful. If you watched them all, or even if you just watched this one, there are videos for practice test 2 as well. Please use those as you find that you need them. That's what they are there for. Awesome.